that I'm working on, Linux Fundamentals Part 2, and we will continue learning Linux Journey with Part 2. You will be learning how to log into a Linux machine using SSH, how to advance your commands, file systems, interactions. Sorry about that. Moving on to Task 1 Introduction. Welcome to the second part of Reworked Linux Fundamentals series. We'll be applying our knowledge from the first installment in this series, so I highly recommend you completing that room before proceeding further. In part 2, we'll be ditching the in-browser functionality and help you get started in what is fundamental skill in being able to log in to and control the terminals of remote machines. Not only this, but the room will also have you unlocking the potential of your first few commands by introducing you to using flags and arguments, advancing your knowledge of the file system to perform some more useful commands such as copying and moving files, introducing you to the access mechanisms in place to keep files and folders secure, of how to identify the things that our current user has access to, running your first few scripts and executables. Moving on to answer the questions below. There is no answer needed, so you just click the green button and we're going to move on to task 2. Moving on to task 2, accessing your Linux machine using SSH deploy. So we're going to go ahead and start our Linux machine. So the browser functionality was used in Linux Fundamentals Part 1 to get you directly connected to your first ever Linux machine without any hassle. In fact, in the browser functionality uses the exact same protocol that we are going to be using today. This protocol is called Secure Shell, or SSH for short, and is the common means of connecting to and interacting with the command line of a remote Linux machine. We'll be deploying 2 machines in this room, your Linux machine and the Try Hack Me attack box. So we're going to go ahead and do that. Start the attack box. And that's loading now. SSH and how does it work? Secure Shell, or SSH, simply is a protocol between devices in an encrypted form. Using cryptography, any input we send in a human readable format is encrypted. For traveling over a network where it is then unencrypted once it reaches the remote machine, such as in the diagram below. And I'm just going to go ahead and zoom in on this. So you have my computer, you have the internet, and you have the Linux server. Moving on, you can learn about the various types of encryptions on Try Hack Me Room, but for now we need to understand that SSH allows us to remotely execute commands on another device remotely. Any data sent between the devices is encrypted when it is sent over a network such as the internet. Deploying your Linux machine. So press the green Start Machine button on top of the right of this task, and then scroll to the top of the page to see the deployment information like so. As you can see, I already have the Start Attack Box machine over here. The IP address displayed is the address of your Linux machine that you will be logging into using SSH. Take note of this for now. Deploying the Try Hack Me attack box. Looking at the top of the page, press the Start Attack Box button to deploy the Try Hack Me attack box that we will be interacting with. The Try Hack Me attack box is an Ubuntu Linux machine that it is hosted online in the cloud and can be interacted with via your browser. You'll be using this to interact with the machine that you deploy in this task. Using SSH to log in to your Linux machine, the syntax to use SSH is very simple. We only need to provide 2 things: the IP address of the remote machine, 2, the correct credentials to a valid account to log in with one of the remote machines. So I'm going to go ahead and get started on that. I'm going to open up the terminal. And if my connection allows me, I will log into this. I will say that right now I'm outside of my college building, so my signal might not be the strongest, but without a doubt I will try. For this room, we will be logging in as TryHackMe, whose password is TryHackMe without the quotation. Let's use the IP address of the machine displayed in the card at the top of the room as the IP address and this user to construct a command to log into the remote machine using SSH. The command to do so is SSH and then the username of the account at the IP address of the machine. So, for example, we're going to type in SSH, TryHackMe, hackme at, and I'm gonna go right here and get the IP address to our virtual machine. So it's 10.10.185.59. So we're gonna go ahead and click enter, and I'm gonna go ahead and read the instructions. So we're gonna go from here. Replacing the IP address with the IP address for your Linux target machine. Once executed, we will then be asked to trust the host and then provide a password for the TryHackMe account, which is also TryHackMe. So right here, we're gonna go ahead and type yes, and the TryHackMe password is not actually gonna like show what the password is, but it is TryHackMe. So go ahead and type that in. Click enter. So now that we are connected, any commands that we execute will now execute on the remote machine, not our own. Note, when you type a password into an SSH login prompt, there is no visible feedback. You will not be able to see any text or symbols appears as you type the password. It is still working, however, so just type the password and press enter to log in. Alright, so moving on, answer the question below. I've logged into the Linux Fundamentals Part 2 machine using SSH. So basically right here, just click the green button and you're set to go. So, now we're moving on to task 3. It's introduction to flags and switches. A majority of commands allows for arguments to be provided. These arguments are identified by a hyphen and a certain keyword known as flags or switches. We'll later discuss how we can identify what commands allow for arguments to be provided and understanding what these do exactly. When using a command, unless otherwise specified, it will perform its default behavior. For example, ls lists the contents of the working directory. However, hidden files are not shown. We can use flags and switches to extend the behavior of commands. So I'm gonna go ahead and type in ls on our virtual machine. So ls, and right here we have imports, my files, my folder, and unknown1. Alright, so using our ls example, ls informs us that there is only one folder named folder1 as highlighted in the screenshot below. Note that the content in the screenshot below are only examples. So basically right here what it's talking about, it has folder1 only. However, using the -8 argument, short for negative all, we now suddenly have an output with a few more files in folders such as hidden folder .files and folders with a period, it seems, or hidden files. So this is what it's talking about right here. So I'm gonna go ahead and type in this -a on lines, and as you can see there's no command for that. However, might be wrong though. So moving on, basically commands that accept that these will also have a // help option. This option will list the possible options that the command accepts, provide a brief description, examples of how to use it, So I'm gonna go ahead and do it on mine. We have ls//help. So that's what appears on mine. So you have usage ls option. I'm gonna see if that's what happened. I'm gonna pull up where we left off. Yeah, there you go. Excuse me. Alright, so commands that accept these will also have so options will list the possible options the commands accept, provide a brief description and example of how to use it, just like you could see right here. So yeah, that's exactly how mine looks. Alright, so moving on. This option, in fact, a formatted output of what is called the man page, short for manual, which contains documentations of Linux commands and applications. The manual page. The manual pages are great sources of information for both system commands and applications available on both a Linux machine, which is accessible on the machine itself and online. To access this documentation, we can use the man command and then provide the command we want to read the documentation. For using our ls example, we would use man ls to view the manual pages for ls like so. So it's showing you, it's typing in the command man and ls, and it's gonna populate this this right here. So I'm gonna go ahead and type it in my terminal. So we have man ls. So as you can see, we have this is what popped up on mine. As you can see, same thing popped up right here. So now we're gonna explore the manual page for the ls command, which we already did. So I'm gonna go ahead and click the green button. So what directional arrow key would we use to navigate the down manual page? And that's basically down. So type in down and click the green button and move on to the next question. Alright, so moving on to the next question. What flag would we use to display the output a human readable way? So we're just going to go ahead and look for that right here. So it'd be this /h. So go ahead and type that in and press the green button, and you're ready to move on to the task 4. Alright, so moving on to task 4, file systems interaction continued. We covered some of the most fundamental commands when interacting with the file systems on the Linux machine. For example, we covered how to list and find the contents of folders using ls and find, and navigating the file systems using cd. In this task, we're going to learn some more commands for interacting with the file system to allow us to create files and folders, move files and folders, delete files and folders. So we're going to move on to more specifically the following commands. So we have the command touch. The full name is touch. The purpose is to create a file. So moving on to mkdir. So that's a make directory, and the purpose is to create a folder. So moving on to command cp. The full name is copy, and the purpose is to copy a file or folder. Moving on to command mv, and that's to move. The full name is move, and the purpose is move a file or a folder. Moving on to command rm, which the full name is remove, and the purpose is remove a file or folder. Moving on to command file, the full name is actually file, and the purpose is to determine the type of a file. So pro tip, similarly to using cat, we provide full file path directory1/directory2, and you have to note for all of these commands. So moving on to creating files and folders, touch mkdir. Creating files and folders on Linux is a simple process. First, we will cover creating a file. The touch command takes exactly one argument, // the name we want to give the file we create. For example, we can create the file note by using touch note. It's worth noting that touch simply creates a blank file. You would need to use commands like echo or text editors such as nano to add contents to the bank file. So I'm just gonna copy what they're doing here. First of all, I'm gonna quit this real quick. All right, so we're gonna have touch, and we're gonna have a note right here. Now we're gonna type in ls. So this is a similar process for making a folder, which just involves using the mkdir command, and again providing the name that we want to assign to the directory. So for example, creating the directory my directory using mkdir my directory. So now we're gonna do mkdir. We're gonna name it my directory. We're gonna press enter. Now we're gonna put ls. And as you can see, we have that on there now, my directory right here. Moving on to removing files in folders, RM. So RM is extraordinary out of the commands that we've covered so far. You can simply remove files using RM. However, you need to provide the /r switch alongside the name of the directory you wish to remove. So we're going to go ahead and type in rm note. Now we're going to type in ls. As you could see, the previous one that we created, my directory does pop up, and we have folder 1. However, that this one right here is just a screenshot, so don't worry about that one too much. So now we're just going to type in again rm. We're going to type in rm. We're going to type /r. Now we're going to put my directory. I'm going to press enter. Now I'm going to type in ls. And as you can see, the one that we made up on top here, we've successfully removed it. So moving on to copying and moving files and folders, CP or MB. So copying and moving files is an important functionality on a Linux machine. Starting with CP, this command takes 2 arguments. So first, the name of the existing file. Second, the name we wish to assign to the new file when copying. CP copies the entire contents of the existing files into the new file in the screenshot below. We are copying note to note 2. So we're going to go ahead and type that in. CP, so note to note 2. We're going to hit enter. We're going to type in ls. However, it might not show on mine because sources cannot stat no such file on my directory, so it's not gonna do it. But that's in theory how do you do it if that actually was on your file or the directory. But here's the example. So right here you have note and note 2. So moving a file takes 2 arguments, just like the CP command. However, rather than copying in or creating a new file, MV will merge or modify the second file that we provided as an argument. Not only can you use MV to move a file to a new folder, but you can also use MV to rename a file or folder. For example, in the screenshot below, we are renaming file to note 2 to be named note 3. Note 3 will have the contents of Note 2. So that's MV, Note 2, Note 3. Type in ls, and right here you have Note and Note 3. So moving on to determining file type. What is often misleading and often catches people out in making presumptions from files as to what their purposes or contents may be. Files usually have what's known as an extension to make this easier. For example, text files usually have an extension of .txt, but this is not necessary. So far, the files we have used in our example haven't had an extension without knowing the context of why the files is there. We don't really know its purpose. Enter the file command. This command takes one argument. For example, we'll use file to confirm whether or not the note file in our example is indeed a text file, like so file note. And there you go. So we're gonna move on to answer the questions below. So alright, so we're gonna move to answer the questions below. So for the first challenge is, how would you create the file name new note? So that's pretty simple. You will just type in touch new note. So touch is the command and new note is the new file that we are naming. We're going to press enter. We're going to type in ls, and as you can see right there, we have new note right there. So second one, on the deployable machine, what is the file type unknown one in TryHackMe home directory? So all we got to do for this one is we'll just type in file, and then we'll type in unknown one. Typed it in wrong. So unknown one, and there you go. Here's the answer to that. So we're gonna skip this step really quickly. So we're gonna type in what are the contents of this file. So that's referring to my folder, of course. So basically we're going to type in cat, the command, and now we're going to put in my file. There's the flag, so just go ahead and copy and paste that. So now we're going to go back to the third one. So for some reason my computer was messing up. It wouldn't get the flag, so I did it that way. But anyway, so how would we move the file my file to to the directory my folder? So that's simple. It's nv my file my folder. Click enter, we'll type in ls, and there you have it. And for the last one, basically just there's no answer, just click the green button and you're set to go. On to task 5, permission 101. As you would have already found out by now, certain users cannot access certain files or folders. We've previously explored some commands that can be used to determine what access we have and where it leads us. In our previous task, we learned how to extend the use of commands through flags and switches. Take, for example, ls command, which lists the contents of the current directory. When using the /l switch, we can see 10 columns such as in screenshots below. However, we're only interested in the first 3 columns. Although intimidating, these three columns are very important in determining certain characteristics of a file or folder and whether or not we have access to it. A file or folder can have a couple of characteristics that determine both what actions are allowed and what user group has the availability to perform the given action, such as the following: read, write, and execute. Moving on, using sudo switch to user2. Let's use the smnatic.pem file. Our initial screenshot at the top of this task has the indicator highlighted that it is a file, and the RW followed after this means that only the owner of the file can read and write the semantic pem file but cannot execute. And it is talking about this right here, guys. Briefly, the difference between users and groups. We briefly explored this in Linux Fundamentals Part 1, namely the differences between a regular user and a system user. The great thing about Linux is that permissions can be so granular that whilst a user technically owns a file, if the permissions have been set, then a group of users can also have either the same or a different set of permissions to the exact same file without affecting the file owner itself. Let's put this into a real-world context. The system user that runs a web server must have permissions to read and write files for an effective web application. However, companies such as web hosting companies will have to want to allow their customers to upload their own files for their websites without being the web server system user, compromising the security of every other customer. We'll learn the commands necessary to switch between users below. Switching between users. Switching between users on a Linux install is easy work that thanks to the su command. Unless you are the root user or using root permissions through sudo, then you are required to know two things to facilitate this transition of user accounts: the user we wish to switch to, the user's password. The su command takes a couple of switches that may be of relevance to you. For example, executing a command once you log in, or in specifying a specific shell to use. I encourage you to read the man page for su to find out more. However, I will cover the /l or // login switch simply by proving the /l switch to su. We start a shell that is much more similar to the actual user login into a system. We inherit a lot more properties of the new user environment variables and the likes. For example, when using su switch to user2, our new session drops us into our previous user's home directory. Where now, after using /l, our new session has dropped us into the home directory user automatically. Moving on to answer the questions below. On the deployable machine, who is the owner of import? And basically how you get this right here, you basically type in ls, sorry about that, so ls /lh, you hit enter, and as you can see, it's user2. So right here on the second question, what would the command be to switch to the user2? So basically the command would be su, and then we'll type in user2, click enter. And then for the third one, says now switch to this user 2 using password user2. So we'll type in user2 for password and we'll click enter. And we've successfully logged in. Now for the second one, output the contents of import. What is the flag? So now we have the output the contents for import. So we'll type in the command cat and we'll type in import now. Important, sorry about that, important. We'll hit enter. And we've captured the flag successfully, and we're ready to move on to task 6 from now. Moving on to task 6, common directories /etc. This root directory is one of the most important root directories on your system. The etc folder, short for etc., is a commonplace location to store system files that are used by your operating system. For example, sudoers files highlighted in the screenshot below contain a list of the users and groups that have permission to run sudo or a set of commands as a root user. Also highlighted below are password and shadow files. These two files are special for Linux, as they show how your system stores the passwords for each user, encrypted formatting called SHA-512. Moving on to /var. The /var directory, with var being short for variables data, is one of the main root folders found on a Linux install. This folder stores data that is frequently accessed or written by services or applications running on the system. For example, log files from running services and applications are written here. /var/log or other data that is not necessarily associated with a special user, database, and the like. /root. Unlike the home directory, the /root folder is actually the home for the root system user. There isn't anything more to this folder other than just understanding that this is the home directory for the root user, but it is worth a mention as the logical preassumption that this user would have their data in a directory such as /home/root by default. /tmp. This unique root directory found on a Linux install, short for temporary. The /tmp directory is volatile and is used to store data that is only needed to be accessed once or twice. Similar to the memory on your computer, once the computer is restarted, the contents of this folder are cleared out. What's useful for us in pen testing is that any user can write to this folder by default, meaning once we have access to a machine, it serves as a good place to store things like our enumeration scripts. Now we're going to move on to answer the questions below. So for the first challenge is just says readme. There's actually no answer needed, so just click correct answer. So for the second one, what is the directory path that would we expect logs to be stored in? And that's /var/log, and we're going to go ahead and type it in so we could apply what we've learned and navigate through these directories deployed on Linux machines. So we're going to put /var /log. We're going to click enter, and as you can see, it gives us this right here. So moving on, what root directory is similar to how RAM on a computer works? And that's /tmp. Click enter, and right here it's telling us it is a directory. Now moving on to the next one, name the home directory of root user, and that's And as you can see, it just gives us this same thing. It's a directory. Now apply your learning and navigate through these directories on the deployed Linux machine, and we've already did that. So we're ready to go to task 7. Moving on to task 7, conclusions and summaries. Nice work. This room was quite theory heavy and covered quite a range of the fundamentals in getting you familiar with Linux. To quickly recap, this room taught you how to connect to a Linux machine remotely using SSH, advancing your use of commands by providing flags, switches, and where you can go to learn about these for each command, man pages, some more commands that you'll frequently be using to interact with the file systems and its contents, a brief introduction to file permissions and switching users, a summary paragraph of the important root directories on Ubuntu Linux, install and how we may be able to use the data stored within these. I encourage you to go through this room again once or twice to gain some familiarity with the concepts. After all, practice makes perfect. Moving on to answer the question below. Proceed to the next task to continue your learning. And we'll just click continue. And we're going to move on to task 8 now. So now visit part 3 of the Linux Fundamentals series. Click here. Basically just click there. So now answer the question below. Terminate the machine from task 2. So we're going to go ahead and terminate the machine. We're going to click complete. Now we're going to join the Linux Fundamentals part 3. So we'll see you in the next room. Thank you guys.